I'm with Juniper. I'm the head of sales for the sales specialist team covering AI and data center for the Americas. So my first NVIDIA show, but not the last. And just really grateful for a chance to speak with you and have the panel here, and also to be partnered with WEKA. So closest to me is Anthony Lembo. So Anthony has got over 15 years of deep technical experience around storage. He's also a global leader for WEKA, and he's known for really leading high quality, high performing engineering teams. So Anthony, welcome, thank you. In the middle here is Mansour Karam. Mansour is the global vice president for data center and AI for Juniper. He was the founder, co-founder of Apstra back in 2014, which got purchased by Juniper in 2021. And he's a just an integral part of Apstra, data center, and our partnership with WEKA. So thank you, Mansour. And last but not least is Jay Wilson. Jay is a senior architect for Juniper. He's got deep experience with collaborating with different types of architectures, including storage and networking. He also leads the team for architects at Juniper. So thank you, Jay. All right. Well, I guess I'll start with you, Mansour, real quick. So why are we here, right? Juniper at an NVIDIA event, and why are we sitting next to WEKA right now? You could just kind of talk about where we are in the data center and why Juniper.
Yeah, no. Well, first of all, thank you everyone for being here and for the opportunity. It's been a pleasure. It's actually, when you think of AI, data center is kind of the foundation for everything that's going on with AI. When you're in a gold rush, you should be selling kind of the what they call them, the pitch, the tools, and we're the tools that everyone needs as they're building these AI infrastructures. Definitely you need the GPUs, but you also need the storage and you need the networking. And it all needs to work harmoniously together if you want to have an ability to deliver on your AI applications. And so yes, absolutely, AI is a big focus for us. It's a big market opportunity. Just the AI workloads for data center and for data center networking are growing at a rate of around 50% year to year. Billions of dollars, out of a data center networking market of around 22 billion, growing to 32, kind of fueled by AI workloads. And so essentially, we at Juniper, as part of the data center team, we're very focused on the AI opportunity and on delivering the right products and the right solutions for AI. And of course, we're partnering with WEKA here from a storage standpoint. Storage is also another critical component. And the way we want to make our customers successful is by delivering these kind of what we call validated solutions, end-to-end designs that bring in all the right components, but ultimately deliver a turnkey experience for our customers, so they don't have to do all of the work themselves. And so as part of these validated designs, working with our partner of our ecosystem partners in storage and on the compute side with GPUs is critical to our success. And certainly, maybe you can present your perspective as well from a storage point of view.
Yeah, absolutely. So one thing I'll mention, I like the picks and shovels analogy, and I feel like there's some commonality, a lot of commonality between networking and storage, especially in the context of what's going on here. We've seen 1,000x plus improvement in compute performance as it relates to AI and these workflows. But networking and storage, you don't hear a lot about. And internally, what we talk a lot about is the infrastructure triangle. There's a foundation that you run all of these upstream applications and solutions on, and that foundation is, compute's part of it, but networking and storage are also big components of that. So balancing them out and making sure there's no weak point is really important, because if you don't think about those things and you start to build an upstream stack, and we've seen this and we can share some perspective on it, that foundation is weak. And the analogy would be like you wouldn't build a house on a foundation that is at risk of crumbling. So you want to build a strong foundation because you can't go back and retrofit these easily.
Yeah, I mean, it's all about balancing all of those resources and the components. It's kind of if your networking is the bottleneck, then your GPUs are left stranded. If you don't have enough storage capacity, you may have way too many GPUs that you can take advantage of. And so, especially when we talk about the cost of these components, it's really sad if a GPU that costs $40,000 is left, kind of unutilized. And so, and not to mention that job completion time, like the time it takes for actually training your model, can get delayed by weeks or months if your setup is not optimized and you don't have the proper balance between all of these different components. So this is really critical.
That's great. So Jay, if I could ask you as well, from an architectural standpoint, what mistakes have you seen customers making when they're trying to roll out, an AI cluster? And how do we solve those together with Microsoft?
So if you didn't hear it, the question was, what mistakes are customers making? I can start with what mistakes we've made. I think that's even a better starting point, because that's fresh in my mind. One of our biggest challenges, and I don't know if this will be common across the user community or not, is there tends to be, at least inside of Juniper, multiple teams that want to use the infrastructure. It's not just one group of people that we say, I want to go and do a training run and get my data set built for my inference. It's literally 5 different teams inside of our company, all vying for this central resource. What's interesting is everybody wants a little bit different when it comes to how they want it to be programmed. And they may actually be running a completely different model. Instead of running BERT, somebody else might be running something like a Llama 2, right? You might be running a GPT-3 or GPT-4. So depending on the workload, the environment needs to change and morph. And we've been our own worst enemy up until probably about 3 or 4 weeks ago, where our engineers were literally just flipping and changing and morphing configs, and people were crossing each other up. We've had this fantastic tool all along called Abstra, which we purchased, which Mansour was one of the founders of. And we've come to this point now where we can eliminate at least that being a contention, because each team now has like this baseline config. And it's super simple from an Abstra standpoint for them to roll back, to say, you know what, this is the setup I need to use, I want this config. And what makes it super simple is it doesn't look at it from box to box perspective. It literally looks at it from the entire infrastructure perspective when it comes to the networking side. It looks at the back-end network, it looks at the front-end network, it looks at the management network, and it says, these are the settings that all need to be applied now, not box at a time. So that's helped us tremendously come over that hump. And I can only imagine when you get into large customer bases, particularly in enterprise, which is my focus, enterprise customers saying, you know what, this cluster needs to be used in this manner. We might want to run this different model. We've got these new set of parameters that we want to try. And being able to have this config that you can easily apply fabric-wide or to multiple fabrics is fantastic. So I would say that's the number one hurdle is when you're thinking about deploying as a customer, start from the very beginning. Don't start later. Start at the very beginning thinking about what are the possible use cases. Find a tool. Hopefully you pick something like Abstra, but I'm not a salesperson, I'm an architect. Find a tool that will allow you to easily morph your environment as your needs change. Because if you don't have the tool, you're going to spend a lot of wasted cycles with those GPUs sitting idle. And that's not something your company really wants.
Yeah. Maybe one thing I'll add is that I think what this highlights is the importance of using the right software to manage and optimize all the various components in your cluster and make them look like one system. And certainly Abstra is a tool I spent 10 years actually of my life focused on. So we're very pleased with the traction Apstra had, but also just generally the difference it makes for our customers, and certainly for AI, it's become like almost something that is necessary, because exactly for the reasons Jay mentioned. Every setup has a different set of parameters, has a different criteria in terms of what makes it perform well. And what you need is a software solution that ultimately has the ability to optimize a cluster in real time and then verify that it's set up the right way by extracting the right telemetry and running tests in real time. And so that capability, that software automation capability becomes that much more important when you need all of the parameters to be balanced across all of the various components in real time on a continuous basis. And the cost of not doing that, again, is very high, both in terms of how long it takes you to train your models and how much of infrastructure is sitting there stranded. And so, I agree with that.
Yeah, I can give you a really concrete example of that. Inside of our development lab down here in Sunnyvale, we have found that the tuning parameters when it comes to the quality of service and class of service need to be slightly different on whether you're running a BERT test or you're running a DLRM test. And being able to quickly know that you're going to be running that DLRM test. Oh, and by the way, here's this baseline config already built, and it already knows what those tuning parameters should look like when we're running that job load. Makes it super simple to not waste cycles going around reprogramming everything and trying to figure out how things need to be tuned. So it is really important to have those tools in place.
And one for clarification, the setup that Jay is mentioning is we have a large GPU AI cluster. WEKA is part of it in our POC lab back at headquarters, and it's integral part of us becoming experts at AI and helping our customers build these AI clusters. It's how we deliver these validated designs that are fully tested. We know how to guide our customers. So we're not just selling a networking component, but ultimately it's about delivering the solution that we know will work for our customers. They don't have to go build it or buy it proprietary from one vendor. We're bringing in all the best of breed components, including, of course, our Juniper switches and the management software, etc., storage from our partners. But then when the customer uses it and deploys it and operates it, they know it's going to run optimally. And so that's kind of like part of the investments that we have done in order to have the ability to deliver that for our customers. Just wanted to clarify.
Yeah, that makes sense. I'll give maybe a storage-specific lens or a WEKA-specific lens of some of what we've seen. And I'll try to give it a networking slant as well. It gets our perspective. So the question was around what mistakes are made. That's maybe a heavy word because I think all of us are exploring in real time, but what we've seen is the things that come to mind around growth and scale. If you think about how these architectures look like from a networking perspective, if you account for what growth might look like, there is a way that if you don't design things accounting for how you expect the storage cluster itself to grow, how many clients are going to expand, there's pretty massive implications to what you might need to do at the networking layer. And we get maybe kind of trapped into that sometimes, where from a storage standpoint, we're very focused on storage. We're focused on scaling on the storage side. But if you're not planning for what happens on the network side, if you quadruple or more the size of the back-end storage cluster, the same thing with the number of clients. There's massive implications to what kind of topology do I use? And then monitoring the health of this is also something else. If you add components, at what point do you hit congestion? And these environments also have levels of congestion that I think are most, especially from the enterprise space, are just not used to seeing.
Yeah, especially when you talk about storage, packet loss, for example, in the network can be disastrous, right? So making sure that the network is set up in a way where it has the capabilities, the features to make sure that whatever happens, no packet is lost, and it's done in the context of this balanced setup, right, between the right amount of networking for the right amount of storage and the right amount of compute. So there are some things that, if they happen, like packet loss, could really have devastating consequences when it comes to the performance of the cluster, and that it's really important that whether it's the software or the whole setup, they're avoided at all costs.
Yeah, specific to our setup, on the WEKA side, we're using your POSIX client.
Yeah.
And that client, we've had tremendous success with, the POSIX client on the storage. We are getting almost the theoretical rate that supposedly, according to WEKA and AMDAL, that you should be able to get out of that storage. And we have experienced 0 packet loss. Now, am I saying everything's a panacea and everything's beautiful? Every once in a while, things will glitch, but it's usually when a team is switched over. One of the teams has taken over and they haven't reset something to the baseline like they meant to, and they'll say, all of a sudden we're getting half bandwidth or something. It's like, okay, did you make sure that you really flipped everything over using the golden base config for you? And it's like, oh, yeah, we grabbed the wrong base config. Flip that over and we're back to, we've had very little issue involved with interfacing with the WEKA storage and the POSIX.
Yeah. There's another, and again, I'll give kind of the lens on just architecturally. Something that I think about whenever we're building a design is how much agility do you have in that design, and just specifically around an AI and ML workflow. And just previously, deep learning actually taxes environments significantly, but in Gen AI we're seeing, and when I say agility, the storage lens is, can I adapt to multiple different kinds of I/O patterns, of data access patterns, and what happens if I flip from one to the next? There's implications on the networking side, but the implications from a storage perspective are substantial. If I'm designing for large streaming reads, and then I have a workflow that a researcher decides to use, which is becoming common, that has a completely different kind of I/O pattern. It's heavy, small random reads or small random writes or metadata or all of the above. How can you absorb that? What infrastructure changes do you need to make? And a lot of times, if you're not thinking about those, you'll get pinched into a corner where the way out is not a clear-cut thing. It's not something that can be patched easily.
Well, on top of that, I mean, this whole market's moving fast, right? So with new cards coming out, GPUs, fabrics, I mean, what do you see in the next 12 months, how that's going to affect, WEKA and Juniper, and especially around the new announcement around the WEKA pod? How's that going to help with customers?
Yeah, I'll take a cut at that first, but it's interesting. I can answer that in a few different ways, but so new cards, new technology, there's one thing that's for sure, we're going to see a lot of new hardware technology coming out. There's new technology coming out from an infrastructure perspective. And something that's just salient based on this conference and what I've seen, but also over the last year for us, as we've seen AI-based workloads with either Gen AI companies or GPU clouds, GPU as a service companies, is basically cooling and thermal. So and then we have situations where sometimes our customers get access to hardware before we do, and then we will basically do a live qualification, which is a great thing to be able to do. So as these new cards are coming out, what we see is very quickly there's this pivot to, I'm not buying the old stuff, period. I'm only buying the new stuff. And we're in a position where we're going to qualify live in place. And there's some interesting things that show up. Like one of them is thermals on some of these cards. Like you get all high bandwidth networking cards, all the latest generation of everything. And there's some unexpected things from a data center infrastructure position that come up. So there's that kind of hovers over it. But it goes back to agility. The question is, let's say a new NVMe drive or a new networking technology is released and comes out from a hardware perspective. How quickly can I take advantage of that? And we've seen this, what I'd call extreme competition to get the latest and push for the latest faster than everyone else. Right? new networking technology comes out, how fast can we get it? New GPUs, how fast can we get it? New switches, how fast can we get them? So how quickly can you integrate those into an environment is something that's important to consider. So all these new technologies coming out, it's how do we absorb these and then leverage them in real time.
Yeah, completely agree. I mean, the field is moving really, really quickly, and we're having innovations every day, and new hardware, new GPUs. Of course, NVIDIA announced their most recent GPU, but we're also seeing GPU announcements from other vendors. I think that what's going to be really important is to have for when you're deploying AI clusters, what's going to become increasingly important is the ability to leverage the latest and the greatest as part of an open ecosystem. And so as much as possible, one needs to avoid kind of locking themselves into just one vendor across the entire stack. And from a networking standpoint, we have a lot of experience with this. Back to the even HPC days, where you have technologies that are specialized and that are more proprietary, like InfiniBand, but at the end, Ethernet is the technology that ultimately wins. And so we're very focused on making sure Ethernet, which is where the entire ecosystem is, where all the investment is in the industry, where you have lots of choice from different vendors, gets to the level of performance and exceeds the level of performance of proprietary solutions. So this is why we've announced our 800 gig switch, which is the first 800 gig on the market, on par or beating in InfiniBand. This is why we have all these AI-specific features around, think of the network as a freeway, so you have congestion control and you have load balancing to make sure that there are no bottlenecks. This is why we're part of the UCE, the Ultra Low Ethernet Consortium, UEC, and that's where all of the standards are being written so that we do have interoperability across all the various solutions. And when you deploy Ethernet, the choice of the network that you deploy and having an open network is what will enable you to support the various GPUs on the market, because Ethernet will be kind of the standard network or the standard way to connect to every one of those solutions. And you're going to have an ability to support the best of breed storage. And so, essentially, one thing to think about is, how do I set myself for success so that I can leverage without changing my entire setup or my entire workflow? How can I leverage the latest and greatest technology, the latest and greatest speed and feed, the greatest and latest innovation that's been available to me? I think that becomes a big and increasingly important consideration.
Since you mentioned Ethernet, I'm going to take it from an architecture standpoint. If you're not following it architecturally, if you look at how Ethernet is trying to further address any concerns when it comes to AI, ML, and granted, these concerns have been around since the HPC days. We've been trying to do things forever. I have a background in HPC, but it was with FCOE, if you recall that, several years ago when we got the lossless queue. Just about every vendor introduced the lossless queue. I see
smile. I see smile on people's faces when you say FCOE.
And we introduced 3 different standards for it to make it work, and it turned out the congestion didn't work. It never worked from the get-go. But if you look at what's happening today, right? They've published DCQCN, and anybody who's doing AI, ML, and talking Ethernet, they're talking DCQCN. One of the standards, the PFC, came from what we did with FCOE. The other standard was introduced as part of trying to get end-to-end notification over IP. But you also need to realize that there's 3 other standards currently in the works. So there's actually a DCQCN plus, there's a DCQCN plus, and now there's an HPCC. So just about every vendor on the market, including NVIDIA, even though they're out there promoting InfiniBand, is participating in these 3 new standards trying to break out. Are all of them going to make it? I don't know. Will one of them make it? More than likely. So it really is important to stay up on what's happening And we as a company, at least Juniper, and WEKA seems to be in partnership with us on this. We're making sure that we are in tune with what is happening in that space. So Ethernet, we do believe, will be the truth, the light, and the way. The way is always prevailed in the end, and time will tell.
One comment on that, I'll just give so we've been in the high performance space, and AI and ML are a subset of that just since we've existed. And what I'll say for sure is, if you think about what I call like a legacy HPC mindset, think about a national lab or a skunkworks commercial organization that has an HPC cluster with a parallel file system. It's always been InfiniBand, but what's clear to me over the last, probably the trend is more like 3 or 4 years, more and more and more Ethernet is emerging as an option in those HPC architectures, and especially from a greenfield environment perspective. If you look at an enterprise customer that moves, they're almost always Ethernet. There's no discussion about InfiniBand. So there's this shift that we've seen happening, and more it's emerging as the first thing that we talk about.
Yeah, I will contradict the vice president one little bit. I've been doing HPC a really long time. Before InfiniBand, it was called MirrorNet. Before MirrorNet, it was called Dolphin.
There we go.
So there's always been something that's come along, and in the end, it's always been called Ethernet. So
Actually, something anyone can do is you can go to top500.org.
Yep.
This is where all of them, and then you can look at the list of the top 500 HPC clusters.
Yep.
And what you see is that the first page maybe like, there is a bunch of proprietary and then you see a lot of InfiniBand. The second page you see some InfiniBand, and then
it's Ethernet.
starting to see more Ethernet. By the third page, like it's overwhelmingly Ethernet, right? And it's kind of like it's always been the case. It's really hard to bet. You bet against Ethernet at your own peril, right? It's where the entire market is, where all the investments are made, and where the entire ecosystem is.
Yeah, probably the biggest challenge, if I don't know if you're InfiniBand people in here or not, is InfiniBand to me, and again, my history is also storage, which is why I was asked to set up here. If you think like Fiber Channel, if you have a background in Fiber Channel is credit-based, and it expects you to acknowledge and tell me how many buffers you have and how much space you can handle, and InfiniBand is extremely similar when you look at InfiniBand. And that's what Ethernet has had, and that's what it gets knocked for, is the fact that it can't account for the buffers. So when you're designing from an architectural standpoint, the things you need to think about is not only can I get it there in a timely manner, you also need to think about, believe it or not, how long my wire is. And this is really critical when you're building these clusters, because you need to think in terms of my delays, my buffer overheads and stuff, and how many packets or how much of a packet can fit on a wire for the distance that the wire is. So there's a little more to architecting when you get into the Ethernet side of it, but it's not insurmountable. It's things that those of us who particularly played in the HPC space for a long time have had to deal with and thought about, and it's no different. You have to think about it in the AI ML space.
Excellent, thank you. I got one more question, and then we'll open it up to the customers and folks in the room. When it comes to like partnerships, there's a lot of new logos here, right? And the AI 100 or 200, there's a lot of alphabet soup, right? So how do we collectively, Juniper and WEKA, how are we helping our partners with their customers? Any suggestions for a partner?
Well, at least maybe if I may, from our perspective, again, this go back to the concept of validated designs and management solutions like Apstra, which are multi-vendor. The way to empower our partners is to allow them to deliver turnkey solutions to their customers while offering choice, right? So, the partners that just sell a proprietary solution from A to Z from one vendor, and there are quite a few of these. Ultimately, all of the profit is being made by the vendor, right? But when you have a solution that is more configurable, that has where the partner can provide options and ask questions to the customers, and based on their preferences or their specific use cases, offer different the flexibility of different solutions. That's where I think the partner can add a lot more value, and then they can be kind of trusted in making those decisions for their customers. Then they can start also adding some services on top if needed, or some development on top. And so the concept for us of an open, validated design, I think, is what we've seen be really helpful for our partners in having them in turn help their customers deploy the right solutions.
Yeah, from our perspective, I sort of completely agree with everything that Mansour said. It comes down to flexibility that we offer. So there's an enormous amount of flexibility from a WEKA perspective, because we do provide software, and there are many, many different kinds of configurations that might make sense in different environments. So from a partner perspective, we provide software and we provide designs regardless of which hardware you choose, which cloud vendor is in the mix. Something else that comes up is just something that we notice is there's this kind of ping pong that happens between cloud and on-prem. So it requires flexibility, but it's providing enough flexibility to build custom designs when it makes sense. And then also at the same time, there's this balance with ease of use. And so I think of Apstra and what it provides at the network level. That's something that I think is sorely needed when you look at how to make something turnkey, but have the flexibility to change components. How do you make things easy, but take advantage of the flexibility that you have that's in place? So on the WEKA side, we can take advantage of hardware in real time. We can run on just about anything out there, is what I would say. But that can also be, we don't want to just put any option out on the floor. So we need partners that can help us craft what makes sense for particular markets. So it's a two-way street that we're very interested in. And then partners, from a networking perspective, we're focused on the data side of things, on the storage side of things. And the networking piece can get complex very, very quickly, especially when you're developing something that's brand new. So the overarching theme is, how do I take advantage of the flexibility we provide, but also wrap that in a way that is very, very simple and predictable?
Excellent, thank you.
Yeah, I was just going to say, for me, when it comes to the partners, it's really about building the right use case. Because if we don't have that right use case, the partnership, at least in my experience, I've been doing this a long time, it usually falls apart. So as long as we identify the right use case and the partner is aligned with that use case, the partnership usually works out really well.
Great point. Thank you. All right, I'll pause. Let's open it up to the audience. Go ahead.
Yeah, so when designing a compute network for GPUs where the workload goes over hundreds of GPUs, the tendency is to have a lowest latency network, which, typically we talk about InfiniBand. How does Juniper kind of works in those areas? And the pros and cons, do you feel like you can replace InfiniBand in those situations? And if yes, what kind of the pros?
I mean, the answer is absolutely, we can. And at the end, when it comes to AI workloads, these are like very much batch. Like there is just a lot of data that needs to go to like specific GPUs at one time, right? And if one parameter is missing, you can't do the computation, right? So it's a lot more about having the right balance, the bandwidth, and also balance with what the GPU can take in, right, at the right time. So it's not necessarily just latency. It's about making sure there is no packet loss, right? That's critical, and it's about having the right bandwidth and the right ability to kind of get the data all in one place. The discussion about low latency versus deeper buffers, I mean, that's discussion has been going on for a long time, and you can mix and match. But from a Ethernet standpoint, you do have very low latency solutions in the hundreds of nanoseconds, which is what our 800 gig switch, 64 port 800 gig switch delivers, very much on par with what NVIDIA has. But then you also have deeper buffer solutions, which can come in quite handy from both from a Radix standpoint, but also to absorb congestion if in the process of sending all the traffic. It's kind of like having bigger dampers, on your car. The combination of these two has been proven to be really powerful, right, and capable in meeting the performance requirements of these AI clusters. And that's part of the testing that we do day in and day out in our internal labs, right, in our POC environments.
Yeah, so to go on top of what Mansour was saying, if you look at the workload, particularly a BERT workload that we've been running in our AI lab up at the corporate office here, we get InfiniBand comes in as somewhere around 2.5, 2.6 job completion time latency for that BERT. That's 2.6 minutes, 2.5 minutes to run that entire BERT training model. We can do that on Ethernet, and we can do it in 2.6, 2.7. There's a little bit of jitter in there. So we're almost identically in line with what you can get with an IB. And again, it's not about latency, really, when you get in that. HPC world is absolutely about latency because MPI is very latency sensitive. RDMA is more about drop packet concerns, because when you drop a packet in RDMA, then you just don't resend that packet. You have to send multiple packets back to get back to a checkpoint, more or less. Again, think like Fiber Channel, where it has to do like a reset and come back to a time point. So the bandwidth is absolutely critical. In the Ethernet world, the buffers, being able to make sure that you tune the parameters correctly for your workloads is definitely critical. Because I can tell you what we've seen if we're not tuning the parameters correctly, that 2.6, 2.7 will jump to 5 minutes.
Yeah.
So it is really, really important to understand what your model needs. And that's one of the reasons I'm really happy that we took the time as a company to invest in building out that cluster, because now our engineers who are building our products can sit there and look at this and go, oh, quality of service and class of service really does matter.
Yep.
Oh, these parameters like PFC and ECN also matter. So
maybe I'll just add maybe a couple more kind of considerations. One is especially when your network becomes super large, then having like a centrally kind of controlled, where like flow per flow you're controlling, which is essentially how InfiniBand works, your network, you can, from a scalability standpoint, you run into challenges. And so I'd say that's number one. And number two is that, again, the ecosystem, right? Like when you're building an Ethernet solution, you have monitoring solutions from many, many different vendors. The state of the art, you have an ability to monitor, you have flow-based telemetry. So all of these come in real handy. Like for example, with Apstra, we use all of that, right? So that we can optimize the performance of the cluster. And so again, the ecosystem comes in handy, right? When you're there trying to deliver the most optimal performance as part of your cluster, and that ultimately has an impact on the performance that you can deliver. Yeah.
Then one question that might be slightly annoying. So you know how Ethernet is kind of a Swiss Army knife networking. It can do a lot, even though maybe not as well exactly as InfiniBand for some things. But one nice thing about Ethernet, it seems to be like it can be all things to all people, it can scale well. But would there be a situation where, and this is going to be where you get really mad, but is it possible to have something like OpenSM for Ethernet? Because of the reason I'm saying that, before you smack me, is that sometimes, like from a security standpoint, not having IP or IB, and be able to go direct and have complete control deterministically of where all the packets go might be useful. Do you see that being available in Ethernet, kind of having a mixed model where it can act more like InfiniBand when it needs to, and act more like Ethernet when it needs to scale in the future?
Well, I'd say I don't know if you guys have it, but I was part of the early efforts with SDN, which were OpenFlow. I mean, you probably know OpenFlow. where it was all about controlling every flow and bypassing like your distributed protocols that have been working well for the last 30 years. And my lesson from kind of me going down that path was that, wow, there is a lot of wisdom in these distributed protocols. There is a lot of wisdom in what the internet protocols, of what this community has built over the last 30 years. So, to me, I find it hard to identify, use cases where, trying to kind of move away from like your standard protocols can really have a big impact. I mean, it was like, for example, in the context of maybe you're a monitoring network, right? There was, maybe controlling every flow was helpful. Maybe OpenFlow had a play there. But I'd say, generally when you're talking about a network, especially in the context of AI, I really don't see a benefit to those approaches. I think it's much better to just stick with the standards.
But I will argue that you can be. So again, I tend to speak my mind.
So I figured you're gonna say that.
I could argue that being completely distributed and just letting it do what it needs to be, what it thinks it needs to do, is the right thing. And I particularly think of this. I was working with a customer. This was a few years ago, and it was not AI ML, it was HPC, and they wanted to spray packets. Spraying packets is not goodness in RDMA. It is not goodness. So you not only do you need to have a special NIC that knows how to reassemble, but you better hope that nothing gets dropped. So yes, is Ethernet fabulous? And I would love for everybody to run Ethernet because I'm a Juniper employee. Absolutely, right? But as an architect, there are just some things that, because you can do it, doesn't mean you should do it. And right now, I would say anybody who says, I'm going to build my AI ML cluster, I'm going to use Ethernet, and you know what? I've got these NICs that know how to take these packets and then reassemble them, so I'm just going to spray them for my most effective use of my bandwidth. More power to you, because I think you're in for a really quick reality, because as soon as you lose one packet, think about everything that was sprayed, and all of it has to be retransmitted from the reset point. So don't let the protocol necessarily, the fact it's distributed, the fact it's open, great, but there are just some things you just should not do. I'm sorry, that's my opinion. So.
Yeah.
Thank you. One more question, yep.
What's the key differentiator between net EMC like compared with backup?
Sorry, could you say that?
Repeat one more time.
What's the key differentiator when compared backup with net app or EMC?
Key differentiator between
NetApp,
EMC, or pure.
And the EMC, I think that.
Yeah. So I think the first thing that comes to my mind when I hear that is the parallel file system or not a parallel file system. So that's the first thing, because I think it makes a big difference if you need to use something like MPI, and so that's the first thing, right? So WEKA we're a parallel file system, so we can operate in that space. And generally, like if you look at those two, or at least comparing those two platforms and us, or what EMC Dell provides and NetApp, a lot of times we look at that and we say, well, one of us is maybe in the wrong space because of the criteria. So if you're looking for a parallel file system that delivers ultra high performance and you're trying to push the boundary, like that's what we're talking about here at GTC, then WEKA is very strong at that, right? And it doesn't have to be, you don't have to be using MPI-IO to get the benefits of WEKA. It's just the software was designed to saturate the underlying hardware that we're running on. So it's a different kind of use case in my mind. Now there could be some overlap there when you talk about a non-parallel file system workflow. And if you look at the differences, I'll just focus on the differences, right? You're going to have to make a decision on what makes the most sense. We're software, and we run on a variety of different hardware platforms. So we're partnered with Dell. We have a strong partnership with Dell. So we can run on Dell server platforms. We can integrate with Dell Object Store as well. So again, it kind of goes back to, well, what is the right solution for the use case? If it's high performance, you're pushing a boundary and you're building a modern AI ML workflow, then maybe I'm biased. I mean, I have a WEKA shirt on. We should talk, right? Because that is the space that we're in, and that's what we're very, very focused on. But if you're looking for something that is that it has a number of features that have been built over tens of years, really, in those platforms, and you have an enterprise-style workflow, that's not something that we want to go after. So again, it's, well, what is the fit, and what does the use case look like, and what makes the most sense? So I hope that helps clarify it. But we're a parallel file system, and those platforms are, and it's kind of the first criteria, and then you go into details and variations based on the use case.
Thank you. Any other questions from the audience?
Right.
Well, panel, thank you very much. Great job
Thank you.
today. Appreciate
Yeah,
it.
thank you. Thank you.